All right, so for question number 1, it says show all your work for each part. It says the dart is launched horizontally from the platform of H, and it hits the target, and it hits the center of the target, and the distance is D from the initial launch point. So they're talking about a horizontal distance. I kind of covered up the word horizontal, my bad. It says the dart lands on the target at time equals T1. On the following axes, go ahead and sketch the graph of the Y component and the vertical component. The vertical, which is the Y, and the horizontal on the X. Sorry, I was reading as I was thinking about how to sketch this. So what we're doing is we're separating the velocity. So when this dart is thrown at the top here, what is the, and I'll do the Y in red. What is the Y velocity the instant it's released?
That's max.
0. Gravity is going to pull it down, right? And then it's going to be the maximum Y velocity just before it hits the ground, right? But now it's also going in a negative direction. So what you could say is you could say that it starts at 0 and it falls at a constant rate. Okay? The slope of this line is actually negative 9.8 meters per second, right? But it's not requiring you to write that down, but that's literally what it is. So that's the Y velocity. Now, what did we say? What did we say about the path of an object in motion, projectile motion in the X direction? What acts upon it?
Friction.
Air friction. So air friction might have an impact on there. Let's assume that it doesn't. Okay? If air friction did have an impact on it, what it would do is it would slow down a little bit. And it said take upward, and this is a critical part of this. It says take upward as positive. So because we're going down, this has to be negative. It has to be below 0 because they defined it as such. Okay? And then if we do the X direction, whatever velocity it starts at, we'll say it starts here. It's just going to be a straight line because it never changes in the X direction. Does that make sense? And then it says, sketch the graph. It says, on the following axis, sketch the graph of the vertical Vy and the Vx, the horizontal, as a function over time as it leaves the platform. Okay, so that one's pretty much answered, right? Let's see what the next thing is. So, by the way, if you sketch that properly, you get 1 point each. Okay, so this is worth, yes?
How are we supposed to sketch on the computer?
+1. You can. You just got to figure out how to do that. Oh, let me back up. You guys are taking the hybrid.
Yeah.
So when you go to so you're supposed to sketch this in your notes when you do this, because you're going to actually have, because you're doing the hybrid, you're actually going to have a booklet that'll correspond with this, and you have to sketch. So basically, your free response questions you have to write out on paper. Yes.
Right now?
Well, it's printed. You could sketch it.
You can't draw it here. How am I supposed to draw a graph in a text box?
Well,
Write out the direction.
you're gonna have to draw it on paper, and then double check your answer. You guys are grading this yourselves.
Wait, I thought College Board was.
No.
Well, when they grade the actual test, by the way, I'm recording, but when they grade the actual test, the FRQs are graded by human beings. Okay? It's Yes.
Like every other classroom.
Okay.
So when you're done with the assignment, you click submit, and it'll show you the scoring sheet,
Oh.
which will show you the right answers. I'm actually looking at the scoring sheet so I can show you. Let me pull it up. You'll actually see this. This is the scoring sheet for that question, and it literally shows you how to get the solution. But more importantly, it tells you how many points it's worth. So when I like here, when you finish part 1, let me go back to where. Well, you'll see it when you're done. So like here, it breaks down how you score the points. You get 1 point if you do this, 1 point if you do that. So that's what I'm literally showing you from that. And you'll have access to that once you submit it. And then once you submit it, then you're going to enter the score that you scored. Does that make sense?
Yeah. Where do I enter the score that?
You got to submit it first. But don't just submit it blindly. If you have questions and you need help on how to get the right answer, then we go from there. Okay? All right. So that's just part A, part 1. Now, for part 2, and it has a B component to it. Let me pull this back up.
We must go back to gas law.
Oh boy, I got a bunch of these up here, don't I?
Where?
All right, so it says, starting with the kinematic relationship, or derive the expression for the launch velocity, VL, needed for the dart to hit its center of the target. Express your answers in terms of H for height, D as in distance, and the physical constants, which would be like G, right? G equals 9.8 negative. Okay. B, the height of the platform is then increased, but the target isn't moved. Indicate whether the launch velocity should increase, decrease, or remain the same. All right. So now for that one, there's a couple of ways you could do this. So we want to hit the target, right? So how do I hit the target? Well, remember, we did this in class. Remember the dart gun? Do you guys remember that?
Yeah.
We did the exact same thing with the dart gun. How did we do that?
No, right here. On the table with a Nerf gun?
Yeah.
No, I remember.
How did we do that? What did we calculate it? Now, it was a long time ago. I don't know if you remember that. We had to figure out the time that it took for it to fall. In other words, the distance was equal to the velocity in the x direction times the time, right? And then we knew the height, right? Remember we used this. We knew the height. Does anybody remember this formula? What was the formula we used to find the time it would fall? Y equals Y naught plus, yeah, Vy naught plus 1/2 times G times T squared, right? So do you guys remember that? So I'm going to write that. I'm going to take those two equations and I'm going to put them down here. I'm going to say y equals y naught plus v naught times t, but this is in the y direction, plus 1/2 times g times t squared. And then we're going to end up with t somewhere. And then we know that d is equal to v sub x times t. Well, what is v sub x? It's just v sub x. V sub x initial, right? Now you could derive this actually from the same. So I think what they want you to do is that this is actually going to be x equals x naught plus v naught in the x direction times t plus 1/2 times the acceleration times time squared. But the acceleration in the x direction is equal to 0 if we ignore air resistance. So this term goes away. If I subtract x naught from both sides, I get delta x is equal to v sub x initial times time. So that's where that comes from. But delta x is really d if we look at the picture, right? And then over here, if I subtract y naught from both sides, I get delta y is equal to, now the initial y velocity is 0, right? V y 0 is equal to 0. So that it cancels, and I'm left with, because g is negative, I have negative 1/2 g times t squared, right? And you could say plus because we're going to put that negative sign in the g. Okay, so you don't want a minus. And then at that point, how do we know where it lands? Well, you could solve this for t, right? So if I solve that for t, what I'm going to have to do is, what is y minus y naught? Does anybody know what that is? Actually, we can't do it this way. I just realized we got to leave this in terms of h. So really, this is my y final, right? And y initial is actually h. So y final is actually 0, because that's where it is when it hits the ground, right? Up here when it hits the ground, the maximum height, y final is equal to 0. And then this is h. So we got to write this in terms of h and d, okay? So now to do that, what I need to do is I need to solve for t squared. So there's a couple ways to do it. I'm gonna toss the h over to the other side. So I'm going to say negative h is equal to 1/2 times g t squared. And then I'm going to multiply both sides by a -1. And then I'm going to multiply both sides by 2, so I get 2h. And then I'm going to divide them by g. And then this is negative this square root is equal to t. That's t1. Then I'm going to take this value, and plug it in over here. So I get d is equal to v sub x times the square root of they said also to write it as v sub l, which is the launch. So v sub x, because it's parallel to the launch site, would be vl. Okay. Oh, not vl. I'm sorry, I got this wrong. And so I have to express my answer in terms of hd and the velocity needed for it to hit its target. So I have to solve for VL. That's what it wants. It wants to find the velocity. And I was right. Vx naught is equal to your launch velocity because it's parallel, right? So up here we have Vx initial, and it's actually equal to the launch velocity because it's parallel to the surface of the ground. So what I got to do is I got to divide by the square root of this stuff, negative 2h divided by g, divided by the square root of negative 2h divided by g. These cancel, and then I have to I can conjugate this. So when I conjugate this, or I could just multiply by the reciprocal of this. So if you do that, you could get this over g, negative g over 2h equals VL. And that's it. So that's only part B. Now here you get, we still have to answer the last question. So what happens, because we have this thing, it says what happens if the height increases? Well, if the height increases, right? If the height increases, the speed should be, so let's do these scenarios. Part B, if h goes up, then our launch speed has to go down. Because if I increase this number, it's in the fraction of a square root times the distance. So this would lower that value. And then it says, the other scenario, that's basically it. That's part B. So you get 1 point for this, knowing this. You could get a point for saying that it would be in the air longer because the time would be greater. and 1 point for the relationship. So you get 1 point for this, 1 point for this.
That's for number
Yeah, for B. And then because if H is higher than your time, T1 increases. So you get a point for that too.
I need to reteach myself how to do.
And that's just question 1. Is that make sense? Does anybody have any questions? Did you see what I did?
Did you? Wait. So for be how do you spell it? Yeah, I don't know how. There's no. Um. So for part A, like the second one, our answer. What was our answer?
Up here,
The second one of part A. No, number one part A.
this
Yeah.
part here, that this is the okay. So let me go over it from the beginning real quick without doing all the work.
Yeah.
Okay, so you're given this. All right. So I'm just going to go through and just point out a couple of things. Basically, this dart, I don't want to, this dart is launched at a velocity going this way. We call that the launch velocity, VL. But because we're launching it parallel to the ground, that is the initial velocity in the x direction. So this is v sub x 0. Now, because we're launching it this way, there is a 0 component of the y velocity. And it has to hit the target. Well, the target is from here to here. That's a horizontal distance that we usually think of as delta x. But they're calling it d for distance. Okay? We know that gravity is going to be a part of it, and that goes in the negative direction. And this is the height. So it says the dart is launched horizontally from a platform of a height h. The dart hits the center of the target, which is d away, the initial launch point. Now here's part A. The dart lands on the target at T1. Sketch the graphs of the vertical Vy velocity and the horizontal velocity Vx. And then lastly, it says take upward direction as positive. So if we think of this in terms of the y velocity, it's a 0y velocity here, and it just kind of falls to the ground. So what does that mean on the graph? Well, I start at 0. We said going down is negative, so it has to go down. On a slight side note, the slope of that, if we were to figure out the slope of this and actually do it in real life, it would be g, negative 9.8. Okay? Because that's the acceleration. Now, in the x direction, it doesn't say anything about ignoring friction. If you, and this is the part about the AP exam, if you were to account for friction and put it in there, they would probably give you credit for it. But they don't say it's frictionless or ignore air friction. But it is a dart, and darts are pretty aerodynamic. So you can make the assumption and not include it. So we don't include it. So whatever your x velocity is, in other words, when I leave this platform, nothing is acting on the x velocity. There's no acceleration, no deceleration. So for the most part, it should remain constant. So you have a straight line for the v sub x. If you got that right, there's a point here, there's a point here. Now for part 2, it says starting with the kinematic relationship, that's a clue to let you know you got to start using the kinematic equations. Derive an expression for the launch velocity needed for the dart to hit its center target. Express your terms of hd and the physical constants as appropriate. Well, I said that g was negative 9.8. That's the physical constant. Then I remember we did this in class. How did we figure out where the target was when we shot the dart off the end of the desk? We had to figure out the time that it took to fall, and we used this equation to figure out the time. And then we had to figure out the velocity in the x direction. Well, we kind of did the same thing. So what I did is I took this equation y minus y naught times vy naught t plus 1/2 gt squared. Yes. And then remember that y final, where it lands, is 0 in the y direction. So that becomes 0. Well, how high is it in the beginning? I don't know. It's h high, right? So this is my y initial position. And y final is 0. Well, this isn't 0. This is h. I'm writing a lot of stuff down. This is equal to h, whatever this. If it's 10 feet, then it's 10. If it's 20 feet, then it's 20, whatever. Or meters. What is our y velocity in the beginning? Well, as soon as you let go of it, it has 0 velocity in the y direction. It's all x direction. Gravity will pull it down. It will increase, but the formula calls for the initial y value. So this is 0. So because this is 0, this goes away. And I'm left with 0 equals h plus 1/2 g t squared.
Pardon the interruption. I have our bus information for this afternoon. Bus 62 is...
Pause the recording in time. All right, cool. So then this is just algebra. I've got to solve for time because that's the only thing I need from this equation. I get all the way down here doing some algebra, and I get the time is equal to this. Now to find the distance over here, I do the same thing. I start with the exact same equation. X equals x naught plus vx times t times 1/2 the acceleration times time squared. The acceleration in the x direction is 0, so that goes away. And then I do algebra. And then the only thing that you need to remember is that when I launch that, it's 100% of the velocity in the x direction. How do I know? We'll look at it. Whatever I launch this at, it's 100% velocity in the x direction, just like the dart lab we did. So then I got to remember, though, also that the relationship, so I have this relationship, but it tells me I have to write an expression to calculate the velocity, the launch velocity, in terms of h and d. So I have to use algebra to solve for v sub l. Now I'm dividing by this square root, but you're really like dividing by a fraction, so you can actually reciprocate that. That's the same as in how I did that. And you guys, I don't know if you might be a little rusty on your algebra. That is really negative 2h over g over d. And this is to the 1/2, right? Well, in order to toss that over to the top, I could say d times negative 2h over g to the negative 1/2, right? Because anytime we pull anything from the bottom of the fraction up to the top, you just change the thing to the negative. Well, isn't that the same as d? You reciprocate that. One of the properties is you could reciprocate that and say g over negative 2h to the positive 1/2. So then that's where you get this from. And then the negative in the negative, because I define g as negative 9.8, the negatives will cancel out once you start to plug in the numbers. They actually made g 9.8 and then in their formula put negative, but I taught you guys differently, so I don't want to confuse you. All that to say, this is the answer. Did that help?